Lesson 9.5, page 420 in your book. Today's lesson is finding the mean, absolute deviation of a set of data. Another measure of variation in your data is the mean absolute deviation. The mean absolute deviation is an average of how much data values differ from the mean. Please record all the information on this page into your spiral notebook and come on back.
Absolute deviation describes the average distance from the mean for the numbers in the data set. This is just one of two methods. The other method you can use to find this is standard deviation, which is the more common use. To find mean absolute deviation, first step you're going to have to do is to find the mean of the data. So we have our data set over here, 87, 94, 72, 65, 97, and 77. So the first thing we're going to do is we're going to find the mean of that data by adding all those numbers up and dividing it by 6. So the mean of that data is 82. The second step is to subtract that mean from each data point. Now, since the format is mean absolute deviation, we actually just want to figure out how far it is away from that number. It doesn't matter if it's positive or negative. So a little quick hint is just to remove all the signs from the answer so they're all going to be positive. So we're going to subtract 82 from each one. And what you end up getting, in this case, is 5, 12, negative 10, negative 17, 15, and negative 5. So if we take away the signs, we have 5, 12, 10, 17, 15, and 5. So that's how far away it is. It doesn't matter if it's to the left or to the right. We just want to know how far away it is from the mean. The third step, which is the final thing, all you want to do is you want to take those and you want to find the mean. So we're going to total those up, and then we're going to find the mean. So in the case for this one, the mean is 10.67. That is the mean absolute deviation. Okay? That's the mean absolute deviation. The closer that number is to 0, the more consistent the data is. One way to get it to be 0 is often all of the numbers are the exact same. So, for instance, if the mean was 82 and all 6 numbers were 82, the mean absolute deviation would be 0 in that case. So the closer it is to 0, the better off it's going to be.
After watching that video, let's take a look at the steps. First, it told you to find the mean of all your data. Number 2, find the distance between each data value and the mean. If you remember in the video, you had to subtract each data value from the mean of the data. Okay? So in their case, it was 82 as the mean. No matter what the data number was on your list, you subtracted it from 82. You came up with negatives and positives. The first clue he gave you was to get rid of any signs. So any negative signs, it doesn't matter. The deviation is either lower than that number or higher than that number. We just want to know how many digits it is from that number. It doesn't matter if it's higher or lower. Step 3, find the sum of the distances in step 2. So now you've figured out the deviation by subtracting. You now can add up all those numbers and then divide the sum by the number of values. Now you have what's called the mean absolute deviation, the middle or the average deviation from your number. All right, so let's take a look at example 1. Here is your set of data. Step 1, to find the mean. Add it up, divide by 8. Your mean of this data is 3. Now, here's where it gets a little complicated in the book. The video, I think, shows it a little easier. But in the book, it now says take your data and plot it on a dot plot with 3 in the middle, and of course anywhere between 0 and 6 is what they did, because 0 would be 1 below the number up here, 6 would be 1 above. All right, so they put all the information there. 3 is your median, and that's obvious because it's right in the middle. Then what they did was they said, how far away from this mean is each number? So you had 1 dot under 1, and that was 2 places from 3. So you write a 2. You had 3 dots in the number 2, and each of those dots were 1 deviation step from 3. So you have 1, 1, 1. Mean. Then you go to the other side. You had 3 4s. They are also 1 step in the other direction, 1 place value, away from 3. So you have 1, 1, and 1 for the 3 dots. And again, you have 2 over here. All right? So now you take all these numbers, add them all together, which is 10. You have 8 numbers again. You divide the 10 by the 8, and you get 1.25. 1.25 means that's the average deviation, average distance away from your mean. Your numbers are an average of 1.25 away from your mean. Please go on to do the on your own on page 420 and come back for the answer. The answer for the on your own is 4.25. You should have found that for your deviation. And interpret that. That means the data values differ from your mean by an average of 4.25. All right, example 2, page 421. What I want you to do is, with a partner, go through this real-life application, go through it step by step so you understand it, talk it through with a partner, do the on your own. Let's just make sure I don't have anything else. Okay, do the on your own, check the book for your answer, and then go back to your packet. And that's it.